Hey folks, welcome to webinar on Python for Big Data Analytics. My name is Balram, and I have been working in this industry for a pretty long time now. I've worked on various technologies, including including Python for a very long time now. It's been more than a decade. Not wasting much time here. Let's get started. So if there are any questions, what I would request you would be to hold on your questions till I finish my slides, and then you can start posting your questions, and I'll respond back to you. The objectives of this class, and at the end of this module, you'll be able to understand Python at a very high level. I don't, I don't say that you'll be able to learn Python completely in just one webinar, but you'll be able to understand what's Python. You'll also be able to understand the power of Python. We will. I'll try to explain how do we do web scraping using Python. I'm going to scrap an IMDb website. Everyone knows IMDb. It's a movies database website wherein you get the movie rating and stuff. I will go and hit that web page, pull out that information, and show it to you real time. Understand Pydoop, Python API for Hadoop. If you guys are already working in big data, right? So the problem is that with big data, because it's built on top of Java, you need to know Java in order to write mapper and reducer. But Pydoop solves that problem. You do not, and also if you are using any other technologies to write mapper and reducer as of today, you know that you have to use the streaming API, right? Using Pydoop, you don't even have to do that. You just have to write mapper reducer in one page, and you can just call it using Pydoop. It's that simple. Implement word count example in Pydoop. We'll try to implement a simple word count example in Pydoop. We'll also talk about integration of data science with Python. I mean, why is Python loved by data scientists, right? Why is Python loved by everyone, starting from e-commerce to medicine to legal to whatnot? I mean, every data scientist in every field love Python. So we'll talk about integration of data science with Python. If time permits, I'd also like to talk about how this beautiful algorithms, you must have heard about Mahouts, right? You must have heard about, if you are from statistics background, you'll know about all those regression models and basically machine learning algorithms. If you already know about it, well and good. It's very easy to implement all of those algorithms using Python, and that's why, again, re-stressing my point, it's loved by data scientists. And finally, we'll implement a zombie invasion modeling using Python. You must have all seen that movies regarding zombies. So we'll talk about, if a zombie bites someone, that person turns out to be zombie, the resurrection of zombie and stuff. And if one person is infected in the whole world, as of today, how many days would it take for the whole world to be zombie? That we'll talk if time permits, okay? Now, why Python? Python is a great language for beginner programmers, since it's easy to learn and easy to maintain. Very simple. I mean, so the way you write hello world in Python is you just say print hello world, and that's it. It's done. It's if you were to be writing this in Java, what you would do is you would go and write public static void main and so on and so forth, right? 7 lines of code just to say print hello world. But Java, it's just one line. So the good thing about Java is that you can start programming straight away. You can learn Python in one day and start programming the next day. But having said that, if you want to do complex programming, it takes time and training. It's not just it's not so easy. I mean, at the end of the day, there are so many things that you would not know, and you would need someone help. So you would need training, or you would need intense preparation yourself. Python's biggest strength is that there's a bulk of libraries which are portable. Now, having said all of this, right, there are thousands and thousands of programmers all around the world programming in Python, contributing to Python. As we all know that Python is an open source programming language, right? So there are thousands the last I heard was there are 50,000 programmers throughout the world who are contributing to building package. Now in Python, you do not have to code everything from base. Let's say, for example, web scraping or pull tweets from Twitter and so on and so forth. You do not have to do everything. Someone who are more brilliant than us, I mean, who have been spending a lot of time in Python would have made all the effort, and then they would have made this beautiful code. All we have to do is import those code and know how to use them. If we are able to do that, half of our problem is solved. So the biggest advantage of Python is that there are so many libraries which are available, and trust me, the problem that you are facing as of today, you are not the only one to have faced this problem on Earth, right? The same problem would have been faced by someone else, and to overcome that, someone would have written a package. So all you need to do is you need to Google for that package, find out the package, know proper implementation of it, and you are done. So Python basically, let's say for example, machine learning algorithm, right? If you were to write a machine learning algorithm on a simple best fit line, let's say for example, if you write that in Java and in any other programming language, that might turn out to be 100, 200, 400 lines of code. But in Python and with scikit-learn package, it's just 4 to 5 lines of code. That's it. You'll be surprised the amount of work that has been done in Python, and all you need to do is import it and use it. That's why it's loved by data scientists, because as a data scientist, I do not want to be spending a lot of time writing code, worrying about the syntax and semantics of the code. As a data scientist, I rather worry about data, right? And that's what it is. Okay, moving on. With libraries like Pydoop and SciPy, it's a dream come true for big data analytics. So these are just two. Pydoop is Hadoop implementation on Python. SciPy is scientific Python. There is NumPy. There is numerical Python. There is Pandas. There is scikit-learn, so on and so forth. Right? It goes on. The package list just goes on. It does not stop here. And of course, it's a dream come true for big data analytics. Growing interest in Python. See, in 2014, it has not really peaked actually. It's just gone up. It started way back in 90s. The development of Python, it was named after Monty Python way back, right? Way back in 90s. But then the interest and growth of Python over years have been steady, and it's just increasing. It's going on, and trust me on this, it's not going to stop. This is going to be the most preferred language of any other language in the whole world that you have seen. Okay, web scraping using Python. I'm going to demonstrate a simple web scraping example wherein I will go to an IMDb website. Let me just show you my screen. Now, I'm sure you have seen this, right? IMDb's website before. I do not have to show you that. So what does IMDb give you? IMDb gives you, if you go here, movies, TVs, IMDb app, it gives you all the description of movies. It gives you the rating, India top, Hollywood. If you say, these are the latest news on Hollywood, top 10 directors, quotes, so on and so forth, right? It's not just that. So here, search, if you do this, so it will give you, one second, let me search on simple feature film, TV, movie. That's a feature film. I want my type to be feature film, release date, I don't care. Okay, let me give, release date is from 1/1/2005 to 2014. Okay, that's my release date. I want to know about genre, action, comedy, and romance. Okay, these are the three types I like. IMDb top 100, and that's about it. Let me search now. Okay, no results. We'll have to go and manage it back. there's no result because 2001 feature film, 2001, 2005, now playing awards, companies. It's recent. It's not giving me any. I mean, normally it should give me a list of movies. I don't know what's going on with IMDb right now. Okay, TV series, TV episode, mini series, videos, feature film. That's all I want. Okay, user rating 1 to 10, number of votes, I don't care. Companies. Is there some bug here right now? I'm not sure about that. I need color, sound mix. No. Okay. I don't know, most popular color IMDb top action movies released one, user rating between 1 and 10. There is nothing. I think there's some problem. There's maybe some maintenance going on right now. But having said that, right? Now let me go here to my watch list, recently added, so on and so forth. So basically, if I were to select this, right now maybe there's some kind of maintenance going on, and hence I'm not able to see it. But otherwise, it will give you a list of movies. Okay. So in that list of movies, I want to do the same thing. I mean, I do not want to go here and use all the search and titles and everything, right? I want to find out the first 500 movies in IMDb list of all times. How do I do that? So let me go ahead and do a simple program here. So I have given the link here. See here. Okay. Now this is based on some other filter. Most voted feature film released 2005 to 2014. That's what it is. Okay. So it says first one is The Dark Knight, Inception, The Dark Knight Rises, so on and so forth. Right. Goes on. So basically, I want to pull out all this information and store it in a file. I mean, if you had to copy and paste it, I mean, you are free to go ahead and say I will just go ahead and copy and paste it rather than writing a program to do it. Very well, go ahead and do it. But for 10, you might do it. For 100, you might do it. For 500, you might do it. But I'm just giving an example. Let's say if it were not to be a feature film, and if you were to be some kind of product, right? Like let's say laptops, design models of laptops from different websites, or clothes. Go to Amazon.com. You want to scrap Amazon.com. How do you do that, right? And there are thousands and thousands of products. It's not possible for you to manually go ahead and pull those data. So what you do is you write a simple program like what I have written here, and then I say run. You see here now the output. It's going on. It's a serial number 1, The Dark Knight, action adventure, 152 minutes, rating is 9, and this is the image, right? Just take this image and you will get the image of The Dark Knight. See, right? So just that way. I mean, and what have I done? How many lines of code have I written? How many lines of code that I have written? You see, the only thing that I have done here is that I have read the URL, which is this, and I put that in Beautiful Soup. After having done that, I'm just finding tables and results. In that, I iterate over each of those tags and find out first the image, the year type, the genre, the runtime, the value. That's it, and I'm printing it. That's all. See, half of this is print statements, which you don't even care, right? The only logic is where I have not printed. So that's the only logic. How many? 10, 15 lines at max? So that's the only amount of line that you have to write in order to fetch all movies. You can do it in even better way. Just look at this. How many lines here? 1, 2, 3, 4, 5, 6, 7. 7 lines. And you get exactly the same thing. Right? Isn't it wonderful that using, and what have I done? I am using two packages, URL-lib2 and Beautiful Soup. All the packages that I was talking about is here. Beautiful Soup and URL-lib2. The way you download your package, if you are using PyCharm, I mean, if you did not know what I'm using, you go to project interpreter, double click on it, and then say BEAUTIFUL, beautiful soup. Just click here and then say install package. That's it, and you are done. Okay, and this is beautiful soup. This is where I write all my code, and you can it's free. You can download it and then play around with it. So that's about web scraping using Python. Now, collecting tweets using Python. So there's one more example now. Say I have written this program wherein it will not just collect tweets, it will go ahead, and there are quite a few packages that has been used here. If you can see it, there are quite a few packages that I have used, and it's not just the tweets that I'll be pulling. I will be pulling those tweets and doing some kind of sentiment analysis, and then say whether that particular person or product has positive sentiment or negative sentiment. Let's see that now. Now I'll not be going into very details of this because I have tried implementing a lot of stuff here. But if you just wanted to pull out tweets from Twitter, it will hardly take you 15 lines of code. That's it. Now it will ask me as to which two persons that I want. Let's say Obama, and which are the other persons that you can think of? Tendulkar. Okay, these are the two persons for which sentiment analysis will be done individually. And how many tweets I want right now? 10. Search Obama. So this will pull you the streaming data, and then you see all that is said. Obama said while looking blah blah blah. It says the sentiment is semi-positive for Obama, and it's going on, right? Okay, that's not for Obama. That's for Tendulkar, I think. Okay, Tendulkar is being processed. This is for Obama. See it here. So all you have to do is you have to pull, you have to make use of a couple of these packages. I've used package OA, UTH handler, stream, and stream listener. The others, JSON, SACE, web browser, codec, CSVs are normal packages which comes default. Some of this comes default, some which you have to download it from the internet, or the way you can download it is just go to File, Settings, Project Interpreter, double click here, just download it. You can do it that way, or you can go to LFD. You can go to this particular website, and there are a lot of packages which are available. Just download the ones that you need and double click on it. So that's about collecting tweets using Python. Now moving on, right? Those are just two examples, okay? Might look to you as though they are very trivial, but it's much more powerful than just scrapping the data from websites or just pulling tweets from Twitter, right? Those are just trivial examples. Using Python, you can do much more than that. You can do big data using Python. Just imagine anything. You can do gene sequencing. You can do genome decoding, so on and so forth. And many people have done that, and there might be packages that you might need to download and make use of those. Now, moving on to big data. What's big data? Basically, it's lots of data, right? Terabytes and petabytes of data. I'm sure almost all of you would have heard about big data. I'm not going to spend a lot of time here. So big data is the term for a collection of so large and complex data that it becomes difficult to process using on-hand database management tools or traditional data processing applications. So big data, the data for big data is not just stored in database, it's stored everywhere. So that's why it's large and complex, and it's difficult to process, and hence it's called big data. The challenges include capture, curation, storage, search, sharing, transfer, analysis, and visualization. So that's how it is. So basically, whatever data is inside database is called structured data. Structured data. Whatever is not in database in your SQL or in your relational database management system, that's called as unstructured. Be it flat file, be it text file, be it CSV, and so on and so forth, right? Be it music, be it videos, they are all unstructured data. So I'm sorry. 2,500 exabytes of new information is 2012. Now it must have quadrupled by now. It's as internet as primary type. It's just going to explode on and on and on. Digital universe grew by 62% last year to 800k petabytes and will grow to 1.2 zettabyte this year. I mean, this is an old story. It must be more than 3-4 zettabytes now. So basically, like I was telling you, big data is used in hospital care as well to monitor what's happening to individual patients by putting in their data and constantly monitoring each and every parameters in their body. If you were to just normally analyze it, you might not be able to do it with current system that we have, but with big data it's possible. And all of this, right, the way Amazon stores data, all this e-commerce stores data, the way they do the recommendation engine and stuff. So they're all on big data, basically. And just imagine the amount of data that Amazon has. Also imagine that as and when you go to buy something in e-commerce, all of you must have faced this, right? You go and try to buy a particular thing, let's say a shirt, and then there are 10 other shirts listed below saying that these are the available options for you. As soon as you buy a shirt, you might be getting options like, why don't you buy a pant because you just bought a shirt, a matching pant. And as soon as you buy a matching pant, the other thing would be, why don't you buy a shoe, right? And so on and so forth. The list goes endless. How is that done? It's using big data and machine learning. So Netflix has implemented big data to store its huge 1 petabyte to store the video of streaming data. I mean, how do you buy movies from Netflix? They're all stored in a huge data pool from where using big data you access that. A trivia, 2009 movie Avatar is reported to have taken over 1 petabyte of local storage at Vetar Digital. Just imagine. So IBM's definition of big data, this is volume, velocity, variety, and there's one more V added to it, which is called veracity. Basically, volume, you need a lot of huge amount of data to be called as big data, and it's not just data, it has to have a velocity, meaning that if you have 1 GB of data stored in your place since forever and it's not growing, then it's not a big data. But if you have 1 GB of data since yesterday and you are adding 100 MB to it every day, it will be considered as part of big data. And it's not just that structured data, whichever data are there in a SQL or in a relational database. It has to have a variety of data like sensor data, videos, image, audios, logs, so on and so forth, and only it's called as big data. Apart from that, there has to be a variety of data, basically veracity, wherein veracity is removing noise from your actual data. Whenever I say removing noise, there are so many unwanted elements in your already existing data, right? When you have volume, velocity, and variety, there are so many unwanted data along with it. How do you cleanse the data? It's the veracity. It's that veracity that you need to take care of. And we all know Hadoop is open source. Anyone can just download it from internet. The latest version of it is 2.x, but the stabler version was 1.x, wherein a lot of companies have implemented and used it. And the concept of Hadoop goes on with MapReduce. I mean, if you talk about Hadoop and you do not talk about MapReduce, then you have not talked about Hadoop, right? So MapReduce, there are a couple of things in MapReduce that you need to take care of. One is the concept of key value pairs. So basically in MapReduce, everything is divided into key value pairs. Let's say you have a line, every line is divided into key value pair. Every word is split into a key value pair. If there is no key that you can see, just a dummy key is taken, and that's how, if you think of, let's say you want to do a word count, which is like hello world in MapReduce, right? What you do is you take the text data, read each line, separate each of those lines, and take the word as key and 1 as value. You just put default 1 to each and every word. You split the entire line, you take word that's key and value as 1, and then later on you aggregate it. There are two main components in your Hadoop and MapReduce. It's SDFS, Hadoop Distributed File System, which distributes data across nodes. If you have 1 GB of data, it just splits the data across how many ever nodes you have and puts it in different machines so as to process. The data is redundant. There is less data loss because there is a factor called replication factor, wherein each piece of data is replicated across your replication factor, and your name node tracks locations. MapReduce, which splits the task across process, and then near the data and assemble the processing happens near the data instead of data going to the processes or processor. The processor comes near the data basically, or the data already exists where the processor is, and that's how the processing takes place. It's self-healing and high bandwidth because if one fails, there is this replication parameter or factor to take care of. The data is not stored in one place, it's stored over a cluster, and job tracker manages the task tracker. Pydoop, basically with Pydoop, all you have to do is, I'm not going to give you a demo on this on Pydoop right now, but with Pydoop what you do is, instead of you writing mapper, reducer, and then streaming it, okay, I'll just show you as to how that is done. So basically, in case of Pydoop, all you do is you just take this, right? You write your mapper, reducer, and your combiner, whatever it is, in one piece of file. In one file, you write everything in one file, and the way you call it is very simple. Okay, let me show you. You just say Pydoop, and then you give the name of the file, word count.py, and then that's about it. Pydoop and word count.py, and then you pass the input wherever it is, input file name, location of input, and your output and location, output location. That's it, and you are done. So basically, with Pydoop, you have to install Pydoop, and you write all your mapper, reducer, combiner in one place. You store that in some location, and you say Pydoop word count.py, or give the complete path word count location.py, and then give your input and output. That's how it is. It's as simple as that. So, and Pydoop, it provides an API for Hadoop MapReduce, which we all know by now. Pydoop has several advantages over Hadoop's built-in solution for Python programming, example Hadoop streaming and Jython. So if you were to use Python to program without Pydoop, you need to use streaming API, but in case of Pydoop, you do not need to do that. Pydoop internally takes care of that. One of the biggest advantages of Pydoop is, as it is SDFS API, this allows you to connect to SDFS installation, read and write files, and get information on files, directory, and global file system properties. So basically, using SDFS API, you can interact easily with SDFS. And the MapReduce API of Pydoop allows you to solve many complex problems with minimum programming effort. I mean, did you see that as to how much code that you need to write? It's just so much, right? Instead of writing everything in Python, your mapper is one line code, 2 lines of code. If you were to write this in Java, it would take you, I don't know how much, forever. Demo, that's what it is. I'm not going to show you this right now because of lack of time, but otherwise it's extremely simple. This is how you execute it, just one line command. Python and data science. So like I have been talking about data science, right? It's the choicest language for data scientists. It's data science is our data scientist. It's called the sexiest job of 21st century. So a lot of things to be done. There's a lot of data right now available in today's world, but not many people know how to process the data, and we are still evolving actually, and we are still trying to make a meaning out of the data. We are still evolving. Python is an excellent choice. I've been saying about that. Python has the range of open source libraries. I've discussed about that. Python and most of its libraries are both open source and free. I mean, that's the beauty of Python. It's open source and free. You can just download it and start working on it. These are the various packages which are available for scientific Python. I would say you have numerical Python for array multiplication, matrix multiplication, so on and so forth. Scientific libraries, you have all those all those functions like RVS and your linear algebra. How do you solve linear algebra and stuff? You have matplotlib, which can draw you graph. You have pandas, which is a combination of all these three. You have IPython, which is the interactive console. Unlike me programming on PyCharm, you can just program on IPython as well, and symbolic mathematics as well, which is there in SymPy. So basically, that's about it. The last thing that I had to say was there are a lot of things here in Python that can be done very easily. Okay. I'll take your questions after this, but let me just tell you, if you look at my libraries here, okay, I have downloaded so many of these. I mean, it can be for each of the work that you do, there can be 3 or 4 libraries, 3 or 4 packages. You have to choose the best one. Just Google, read about it, download it, and then you'll know which one to use, or based on your usage, you'll know which one is better fit than the other one. Okay. So that's and start using Python. I would say start using Python for some of your basic stuff, and you'll be amazed with how Python can help you, slice and dice the data, play around with the data. That's about it. Okay, guys. So thank you.